Welcome to solverfy.
So the demand for light bulbs can be characterized by Q is equal to 100 minus P, where Q is the millions of boxes lights sold, and P is the price. And then there are two producers of lights, Everglow and Dimlit. So we have Everglow and we have Dimlit. And they have identical cost function as CI is equals to 10QI plus half QI squared, I equals to E comma D, and then Q is equals to QE plus QD. So first question is, unable to recognize the potential for collision, the two frames act as short-run perfect competitors. What are the equilibrium values of QE, QD, and P, and what are each frame's profits? So we're going to be starting with that question first. So in a perfect competition price, the price is equated with the marginal cost in short run to calculate the level of output. So MC has to be equal to the price, and MC is going to be equal to 10 minus QI. Okay. And then output will be equals to be MC is equal to this, so output to be equal to MC. Output to be equals to P equals to MC, because the price has to be equals to the marginal cost in a perfect competition. So yeah, 100 minus QI is equals to 10 plus QI, right? And then QI will be equals to 45. And then therefore the price will be equals to 100 minus QE plus QE plus QD, and then P is equals to 100 minus 45 minus 45, and then P is equals to 10. So the profit of one firm would be equals to PQ minus cost, and then it will be equals to 10 multiplied by 45 minus 10 multiplied by 45 plus 1 over 2 multiplied by 45 squared. And then this will be equals to minus 1012. So none of the firms earn profit because this is negative. So this is a loss. None of the firms earned profit. So moving on to the next question. Top management in both firms is replaced, and each new manager independently recognizes the oligopolistic nature of the light bulb industry and plays coordinates. What are the equilibrium values of QE, QD, and P, and what are each firm's profits? So in a coordinate Nash equilibrium, the profit to be determined as PQ minus cost, and then this will be equals to 100 minus QE minus QD, then QE minus 100 minus 10 QE plus Q squared E divided by 2. This is equals to 90 QE minus 1.5 Q squared E minus QE QD. So its marginal revenue 1 is just the incremental revenue. R1 resulting from an incremental change in Q1. So marginal revenue 1 is incremental revenue resulting from an incremental change in output Q1. So the MR1 is equals to the change in R1 divided by the change in Q1. So 0 is equals to 90 minus 3QE minus QD, and then QE is equals to 30 minus QD divided by 3. And then this is equation 1. So since the delimits bulb 2 as the same cost, its reaction function will be the same. So QD will be equals to 30 minus QE divided by 3, and then this is equation 2. So substituting the values of 2 in equation 1, so we substitute 2 in equation 1, and then QE is equals to 30 minus 1 over 3, open bracket 30 minus QE divided by 3, and then this is equal to QE is equals to 30, and then QD is equals to 30. So substituting the values of both outputs in the demand curve, the price will be substituting values of both outputs in the demand curve. Price will be equals to 100 minus 30 plus 30, and then price will be equals to 40, because 100 minus 60 is 40. So the profit from both firms will be equals to profit of both firms will be equals to 100 minus 30 minus 30, 30 minus 10 multiplied by 30 minus 30 squared divided by 2, and then the profit is equal to 450. So moving on to the third question. Suppose that Everglow's manager guesses correctly that Dimlit is playing Kernot. So Everglow plays Stackelberg. What are the equilibrium values of QE, QD, and P, and what are each firm's profits? So if Everglow plays a Stackelberg leader, then we're going to calculate the profits function. So Everglow plays a Stackelberg leader. So its profit function will be PQ minus cost, and then profit will be 100 minus QE minus QD, open brackets, QE minus 10 QE plus Q squared E divided by 2, and this is equation 1. And then the reaction function of QD will be equals to QD is equals to 30 minus QE divided by 3, and then substituting QD in equation 1. The reaction function of Everglow would be 60 QE minus 7 over 6 Q squared E. And its marginal revenue, again, is the incremental revenue resulting from an incremental change in output. So the marginal revenue 1 is equal to the change in revenue 1 divided by the change in quantity 1. So 0 is equal to 60 minus 7 divided by 3 QE, and then 25.7 is equals to QE. So substituting the value in the reaction of QD, we can say that QD is equals to 30 minus 25.7 divided by 3, and then QD is equals to 21.4. So now substituting values of both the outputs in demand curve, the price will be substituting values of outputs in demand curve, price would be P is equals to, I'm so sorry, P is equals to 100 minus 25.7 plus 21.4, and then P is equals to 52.9. So now the profit from both firms will be 52.9 multiplied by 25.7 minus 10 multiplied by 25.7 plus 25.7 squared divided by 2, and this is in a bracket, and then the profit will be equals to 772. I'm sorry, this is QE. This is for E, and then the other company, the profit for this is for E, and then this is for the other company, which is Dimlit. 52.9 multiplied by 21.4 minus 10 multiplied by 21.4 plus 21.4 squared divided by 2, and this is equal to the profit for company D. For D is equal to 689. So therefore Everglow, as you can see, is an advantage. So then moving on to the last question. If the managers of two companies collude, what are the equilibrium values of QE, QD, and P? What are each firm's profits? So if the two companies collude, which means they will join hands together, that means that the industry cost CT will be equals to 10Q T plus Q squared T divided by 2, and then marginal cost will be equals to 10 plus QT, and then the price will be 100 minus Q. So therefore revenue will be 100 minus Q, and then this will be 100Q minus Q squared. So the marginal revenue again is just incremental revenue R1 resulting from an incremental change in output. So marginal revenue 1 is equals to change in revenue 1 divided by change in quantity 1. And then marginal revenue is equals to 100 minus 2Q. So since marginal revenue is equals to marginal cost, right? The industry output will be equals to 100 minus 2QT equals to 10 plus QT, and then QT will be equals to 30. So if the outputs divided equally between them, if this output is divided equally between them, the firm will have 15 output A. So the firms will have 15 outputs each because it's going to be 30 divided by 2, right? So now, substituting the values of both firms in the demand curve, the price will be equals to 100 minus 30, and then price is equals to 70. And then the profit of each firm will be equals to the profit equals to PQ minus cost. So the profit is equals to 70 multiplied by 15 minus open bracket 10 multiplied by 15 plus 15 squared divided by 2, and then the profit, each firm's profit would be 787. So this is for each firm, and this is their profit. So that's the answer.